Hey, Mr. Hayes here from Hayes' World of Math. I'm here to help you get ready for the AP Stats exam. We are going through the different parts of probability, and we're going to be looking at, in this video, the 2019 free response question that dealt with probability. There's actually two of them. This is the first of two. Problem number 3. This one's pretty straightforward. It's two-way tables, and it's going to be a lot of the ands and ors and givens. So let's take a look. Before I forget, all of this is linked down below in the 3-week review course. It's all free. Download it. There's links to everything that you necessarily need to do. Obviously, also while you're down there, throw a comment about what part of probability you like the best, and maybe even subscribe. And then that way you can get the new ones as I update the new videos from the last couple of years. Anyway, so medical researchers surveyed a large number of men and women about whether or not they take medicine as prescribed. Here are the responses. One side we have men and women. We've got men and women over here. Here is the sometimes, always, never, and then they have the totals there. So one person from these surveys will be selected at random. So because of that, and then we just have to see what the conditions are. So what is the probability that the person selected will be someone whose response is never and who is a woman? So this is an and. Okay, that means that both have to happen. So the probability is never and a woman. So you need to have both of those. So the probability of man and woman is 0.063. Why? Because I want never and a woman. This is just all straight probabilities. They're not even having you divide this stuff out. It's kind of nice. Second part to this one, they ask you, what is the probability that the person selected will be someone whose response is never or who is a woman? So same idea. So the probability that you have never, remember, is going to be this. The probability that you pick somebody who's never is 12%. The probability that the person picked as a woman is 53%. So initially when we did this back, when we went through this unit, remember we would add those two together, and then we said, wait a second, there's an overlap. So the way that you do that then is we're going to get rid of the overlap. So the probability of never or a woman is the probability of never, plus the probability of being a woman, minus the probability that you're both, because they've already been counted twice. So 12% for never, oops. So we have 12% for never, there's the 53% for women, and we have to take off that overlap that we had before. So your answer is going to be 50.5864 is your probability. Similarly, down over here is what's the probability the person selected will be someone whose response is never given that person is a woman. So if I go up here, we have already made the selection. Okay, we are already in this. So we know that we're in that 53%. So then we're going to say, what's the probability of never, what percentage of that group is, of the 53% is never. Now we know that that is 0.636 or 0.0636 for the entire group. So to do that, we need to divide that out. The probability that never given a woman is that it's the probability that both things happen. That should be an and. So that's the 0.0636 divided by this group that we're in, because remember, probability is equal favorable overall. So here's my entire group. There's everybody. There's the favorable group that nobody did it. So then we divide that out and we get a probability of 0.12. When you're doing probability problems, you need to go slow down enough so that you don't make any mistakes. By the way, speaking of slowing down, if I'm talking too fast, hit the settings button. You can slow me down, or just hit pause and take a look at stuff. Backside. For the people surveyed, are the events of being a person whose response is never and being a woman independent? Justify your answer. So technically, for it to be independent, remember, is the probability of never equal to the probability of never given that it's a woman equal to the probability of never given that it's not a woman? So to do this, the probability of never is 12%. We just figured that out, right? But that's the probability of never is 12%. If we look back over here, there's 12% there. And the probability of being a woman, or of never if it's not a woman, oops, I forgot those just disappear. Go back. is 12%. So then you'd also need, you could also go, what's the probability of, oops, we'll just do it over here. And then this last one over here would be the probability of both divided by 0.47. So the probability of being a man is 564. It was such a good idea when I set it up. And if I divide that out, which I wasn't planning on doing, so pardon me, you also get 12%. So they are independent since, and then I would just write all of this out. Probability of never equals the probability of never given woman equals the probability of never given not woman. And that's all equal to 12. Assume that a large population, the probability of a person will always take medicine as prescribed is 0.54. If 5 people are selected at random from the population, what is the probability that at least 4 of the people will always take the medicine as prescribed? So I want to know what's the probability that X is going to be greater than or equal to 4. A couple of different ways we can look at this, remember, because sometimes you want to take the shortest way. So that means that it's equal to the probability that 5 people took their medicine plus the probability that 4 people took their medicine, which is the same thing as 1 minus the probability that 3 or fewer took their medicine. This right here will be helpful because remember, for binomial, and this is binomial because you have a yes or a no. Did you take your medicine or did you not? Are you in the group or are you not? Or did you take it always, I think, right? Yeah. So then what will end up happening is that for this, we can then punch it into here. I can do the binomial CDF. You've got a total of 5 trials. The probability that they picked is 0.54, and the X that we want is 3. Now remember, since it's cumulative, it's going to do 3 and 2 and 1 and 0 and add it all up. Could I do these separately? Yes. It's going to take more time. So you really should hopefully have a good grasp on the distribution functions on your calculator. Your final answer then is going to be this. The probability that, I'm missing an X, is greater than or equal to 4 is going to equal 1 minus what this answer was, which is 0.759. So it turns out that the probability of having 4 or 5, that at least 4 of the people will always take their medicine, is going to be 0.241. Okay, I'm going to put the rest of the probability free response questions here, right there. And then I'm also going to go through and I'm going to put the next unit that we're going to go through up here. Now, again, you can go back to the link down below, find everything from all 9 units, and we'll go from there. So we'll see you next time.